Hey everyone, welcome to this explainer. I am so thrilled to have you here today because, well, we're looking at something absolutely fundamental to our modern lives, but it's something we literally almost never stop to think about. We're going to explore the translation journey. Like, how exactly do computers experience the world? How do we take our incredibly messy, physical, analog reality and translate it into those crisp digital signals that a machine can actually understand and use? It's like a giant puzzle. Let's look at the roadmap.
Okay, let's dive into this. Here is how we're breaking it down today. First up, we'll look at the core IPO cycle. Then we'll cover touch, specifically keyboards and mice. After that, we'll get into sight and sound inputs, followed by automatic data and sensors. Then we'll flip things around with output displays and wrap it all up with tech in our daily lives.
Starting right off with Section 1, the core IPO cycle. And this brilliantly illustrates that foundational concept. To understand any device, whether it's your smartphone or a massive supercomputer, you kind of have to frame it as a brain that relies entirely on a continuous data translation loop. We call this the input-process-output concept. Notice how the data actually flows here. It starts with input over on the left, travels right into the central processing unit, where a program interacts with it and accesses storage, and then it flows out to the right as something completely new. This flow, it's literally the heartbeat of all computing.
To really cement this 1, 2, 3 journey, just think about baking a cake. Your input, that's your raw data, so your flour, sugar, and eggs. The process is the program, right? That's the actual baking happening in the oven. And the output is the meaningful information, the delicious cake. So raw data goes in, the program does the heavy lifting, and useful information comes out.
Moving right along to Section 2, touch, keyboards and mice. So how do we actually get those raw ingredients into the system in the first place? Well, first we have to connect these input devices to the machine, either physically or virtually. Up top, you've got your traditional wired connections, those super reliable, secure USB ports we all know. Down below, we've got our wireless options. These use RF technology, Bluetooth, or Wi-Fi to just zip data right over the airwaves. But here's the thing, both do the exact same job. They create a pathway for your physical touch to enter the machine's brain.
And you know, the absolute most iconic tool for that physical touch is for sure the full-size keyboard. Think about it. It's essentially this massive grid of over 100 different buttons. The mechanics behind it are actually pretty elegant. Every single time you press a key down, you're sending a highly specific, totally unique digital code directly to the computer. You type a letter and boom, the computer gets a distinct numerical signal telling it exactly what you just did.
But typing isn't our only way to reach out and touch the digital world, is it? On the left here, we have your standard, everyday motion tracking mouse. It tracks movement on a flat surface using LED or laser sensors so you can click around an interface. But look on the right. Here we have highly specialized positional tools, like a joystick and a racing wheel. These are built for realistic gaming or, learning to drive in a totally safe simulator. They track incredibly complex positional data, which gives you a completely different type of control compared to your standard mouse.
Of course, nowadays we're seeing traditional mice being increasingly replaced by touchscreens. And these are fascinating because they act as both input and output devices all in one. But there's a real trade-off here. On the plus side, touchscreens give us way easier hand-eye coordination, and they take up a lot less physical workspace. However, they are definitely more expensive. Plus, it is incredibly difficult to do nuanced stuff, like a mouse-over-hover state, which a traditional mouse just handles effortlessly.
All right, let's shift gears. Section 3, sight and sound inputs.
Moving from physical touch over to media, how exactly do we help a computer literally see our documents? Well, we use image scanners paired with something called optical character recognition, or OCR. And guys, this is a brilliant piece of tech. It doesn't just snap a dumb picture of a page. OCR actually scans a flat physical document and smartly extracts the readable text. It converts it into a fully editable, completely searchable digital text file. It's an absolute game changer for data entry.
Now, what's really interesting about this slide is how we handle audio, because we have two totally different methods here. On one side, a standard microphone takes the messy analog sound waves from the real world, just like my voice right now, and it converts them into electrical signals to build a digital audio file. But on the other side, a MIDI keyboard does things entirely differently. It doesn't record sound waves at all. Nope, it stores the exact pure data of musical notes or digitally sampled sounds. And the cool part about that? It means it is completely unaffected by any random background noise going on in the room.
Next up, Section 4, automatic data and sensors. So what about all those inputs working entirely behind the scenes? Honestly, our devices today are absolutely packed with tiny, automatic sensors that are constantly reading physical environmental qualities. They use light sensors to automatically adjust your screen brightness, ultrasonic sensors to gauge distance, compasses for direction, temperature and humidity sensors for climate, and gyroscopes so they know exactly how you're tilting the device in your hand. They're just constantly reading the physical world and quietly translating all of it into digital data.
Let's move to and see how this builds visually. This automatic data capture evolves even further when we look at optical readers. Check out the classic 1D barcode on the left, that sequence of characters we see universally in retail. But look at its evolution on the right, the quick response or QR code. Because a QR code uses a two-dimensional grid instead of just a straight line, it can hold super dense text strings containing any type of characters. This vastly increases the amount of automatic data a scanner can pull with just a single click.
And for the ultimate automatic input, well, we just look to ourselves. Biometric devices scan our totally unique physical or behavioral characteristics. So instead of having to type out a password on a keyboard, a biometric scanner reads the incredibly intricate, individual patterns of your fingerprint. It literally uses your biological data as a secure digital key to unlock the system. No way you're forgetting that password, right?
All right, moving into Section 5, Output Displays. Okay, so we've successfully fed all this data into the processor. How does the computer actually talk back to us? When we want to assess the quality of a digital image on a monitor or a projector, there are a few specific technical attributes we look at. First, pixel density, measured in DPI or PPI, which dictates how sharp an image looks. Then color depth, which is the number of possible colors squeezed into a single pixel. We also have aspect ratio, which is simply the width to height proportion of the screen, like your standard 16:9 for widescreen. And finally, the refresh rate, measured in hertz, which tells us exactly how many times per second the display is updating its image.
Man, display technology has evolved so much over the years. Just consider modern LED backlit LCD monitors and compare them to the older halogen bulb setups. Modern LED displays are fantastic because they use way less energy and they can instantly display dynamic video and constantly changing info like the time or the weather. Now, older halogen setups might have been cheaper to buy at first, but they were entirely static. Like you literally had to manually prepare and swap out physical plastic sheets every week just to update the information. Can you imagine?
Bringing us to our final part, Section 6, Tech in Daily Lives.
Let's bring all these input, process, and output concepts together and look at commercial applications like electronic payment systems or point-of-sale terminals. The next time you're at a store, I want you to really think about that self-checkout scanner. By automatically reading QR codes straight from your smartphone, the system translates your digital wallet data into a physical transaction in a matter of seconds. This heavily reduces labor costs and dramatically speeds up the entire retail process for everyone.
So, the crucial point is how these specific combinations of cameras, touch screens, and processing power completely empower our educational and public spaces. Just think about it. We use video conferencing for interactive online lessons. We use self-charging library terminals to check out our own books. And interactive museum exhibitions, they allow us to dive deep into a collection without ever needing a human tour guide. All this hardware works together to create these incredibly seamless, autonomous experiences.
We started this journey with the humble keyboard, sending basic digital codes, and we've ended up talking about ambient sensors and advanced biometrics. It leaves us with a pretty fascinating thought. As optical scanners get faster, as environmental sensors get smaller and smaller, and as biometrics get smarter, are we even going to need physical keyboards in the future? Or will the computer's ability to seamlessly experience and translate our world make manual input totally obsolete? It is definitely something to chew on the next time you tap a screen or scan your fingerprint. Thanks so much for exploring the translation journey with me today.